Hello, grade 10s. It's me again, Hector Ngosi. I'm here again for mathematics. This is our day 2 of week 9. I'll be taking you for mathematics as usual. We're still looking at functions. Um, those who have just joined us today, please feel free to ask me questions on the chat box. Our class is very exciting. You can always ask questions. If you want to project your voice, also let me know, raise up your hand. I can always unmute you. Our class is very fantastic. The kids are amazing here in this class. I would like also to welcome all the people who have just joined us today. I can see some other new faces today who have just joined us. I'm saying welcome to you guys. I see Bona. I can see, okay, the other ones um, as usual. Okay, there are two Aarons also. I don't know. I know there's a normal one. I'm not sure who's the new one because I see two Aarons. Okay. But nonetheless, guys, let's start with our today's lesson. I just want us to recap on what we were doing yesterday. So those who have just joined us, remember, if you've got any queries relating to maths, you can always email me at nkosihector28@gmail.com. We're looking at functions part 2. Functions are part of your paper 1. You remember in maths, you've got 2 papers when you write your full exams. You've got paper 1 and paper 2. So functions forms part of your paper 1. And now we'll be looking at the question that is adapted from DPE November 2018, question 5 and 6. And today's date, it's 26 May 2020. I hope everyone is ready. You have your calculators with you. You have your paper and pen because we know we are mathematicians. We're doing lots and lots of calculations, boys and girls. So I'm expecting everyone to have everything with them or in front of them. Okay, cool. So yesterday, I've tried to recap with you using this slide. So basically, guys, when we talk about learning outcomes, these are the things that you need to know at the end of this chapter, right? Or at the end of the lesson. But I'll just base it on the chapter because functions are the broader chapter of maths. You know, you're going to find them in grade 11. You're going to find them again in grade 12. I remember back then in the days, I won't tell you which year, but back then in the days when I was doing grade 12, so when I was sitting for my prelim paper, I actually scored total for this chapter. I remember when my teacher called me and he was like to me, you know what, Hector, you did so well in this chapter. So I love functions, guys. It's one of the chapters I like a lot, but you have to know your basics of algebra first before you can master your functions. You need to know how to solve for x, you need to know how to factorize, you need to know whatever you did in term 1. It's very important, guys. You'll see, even when you start trigonometry next week with the new teacher, you'll see it's just going to make sense, guys, if you know your algebra, your maths, your grade 10 term 1 maths is very important, guys. It gives you basics, it gives you things that you need to know for the rest of your life, guys. Please don't take it for granted. If you there are still, there are things that you still don't understand from term 1, please make sure, guys, I'm begging you that you understand them. You don't go to term 3 or term 4 without, or going to the next grade without understanding them, because that's your core or your fundamental maths. That's where you learn about a lot of things, because I'm telling you right now, guys, if you know how to simplify using algebraic expressions, you'll never go wrong. If you know how to factorize, if you know how to solve for x in a quadratic equation, in a straight line equation, or in an exponential equation, if you know your laws of exponents, all of those things, guys, they form part of your algebra. Okay, so just a recap. So I'm going to show you these formulas every day before we start the lesson up until we finish with our functions on Friday. So I'm going to remind you constantly every day about the straight line graph that its equation looks like this. The parabola graph, its equation looks like this. The hyperbola graph, the exponential graph, right? So guys, if the graph is being drawn to you, you need to be able to identify whether is it a parabola or is it a hyperbola, is it an exponential graph, is it a straight line graph, right? You need to be able to do that, boys and girls. Once you are able to do that, you will never ever go wrong. Does it make sense? Perfect. Okay. So we need to finish off on what we were doing yesterday. So basically yesterday we looked at this question, question 5, right? But however, we were supposed to do 5.3 and 5.4. So today we'll be looking at 5.3 and 5.4. We did 5.1 and 5.2. So 5.3 and 5.4 and question 6 today. That's what we are looking at. You know, the whole of question 6, we have to finish it today. Yeah, and 5.3 and 5.4. We did 5.1. I hope everyone still understands what we were doing in 5.1. Everyone still understands on what we were doing in 5.2. Right. So basically, guys, here, remember here we were given what? A parabola graph, and it's given by f of x. And also we're given an exponential graph, right? So we're also given an exponential graph. A hyperbola graph, guys, you'll see it by, say, if you want to see it by inspection, it will be drawn in quadrant 1 and quadrant 3, or quadrant 2 and quadrant 4, right? That's a hyperbola graph. But if it's a graph like this is an exponential graph, guys. And you can see by its equation or its formula that, I mean, this is to the power of x, therefore it's an exponential graph basically, right? Because I know majority of you they are still worried on how do we see whether this is a parabola, how do we see whether this is an exponential, how do we see this is a straight line. Remember the straight line graph, guys, you did them from grade 9. Your straight line graph is the one that says y is equals to mx plus c. All right, so let's look on what we are given today. So now we're still continuing with this activity. So 5.3 says determine the length of CD. So now let's look at CD. Where is CD? So that's C and that's D. What will be the length of CD? Remember there was a question where they wanted the coordinates of D. That's 5.1. And there was a question where they wanted the coordinates of C. But remember, coordinates of C, it's the turning point. It's the turning point of f of x, right? So it's where your f of x touches your y-axis, right? And we said C is given by the value of Q. So by now, you should know what is the value of Q, which means because the value of Q, it was asked from us in 5.22, right? So if you know the value of Q and you know your 5.1.1, you can calculate the length of CD. It's either you can do it by inspection and see that, okay, if there it's how many units, there it's how many units. Therefore, from there to there, it's so much units. Or you can do your distance formula. However, your distance formula, it's always going to take time for you unless you don't have any other options. I mean, because it's only 2 marks, but any answer is acceptable, guys. Remember, sorry, at the end of the day, you need to know what's right for you and what's working for you, boys and girls. So now, who can tell us what is the length of CD? Okay, I need to increase my screen. Perfect. The length of CD, guys. Okay, I can see others are still joining us. They are late for class. Guys, remember we're starting exactly at 2 o'clock sharp. So please make sure that you try to log in on time, so that you don't get delayed, you don't miss out what we're doing, so it's going to be helpful to you. So make sure going forward that at least by 5 to 2 you log in, and you just wait for 2 o'clock, because time is money, guys. We're working on time, right? Perfect. Let me see. Aaron got 7. Ontatile also got 7 units. So Kamogelo, you asking, said, do we use the distance formula? Yes, you can use your distance formula. It's up to you which one you want to use. It's either you can use your distance formula, or you can use the what you call the inspection formula, as I explained earlier on to you guys, right? So between Ontatile and Aaron, do you guys want to share how you got your 7 units before I can project the answer to everyone, or before I can explain to everyone, right? Remember, guys, the more the merrier. I can learn new things from you. You can learn new things from my side also. So that's why I love the interaction, guys, because there are so many ways to kill a cat. There's so many things you can do in maths in order for you to achieve whatever you want to do, guys. As long as you use the logic answer, or you use the very same thing. All right. Okay. Okay, on Tatile, I'm about to I'm about to unmute you. Okay. Okay, let's go to on Tatile. I need to type on Tatile. Okay, found him. Hi, my boy, how are you?
I'm good, and you, sir?
I'm okay. So do you mind to explain to us how you got 7 units?
Yes, sir.
Okay, let's go
So,
to our graph. Yeah.
so then, sir, because we already knew that d was 0 and -3, and because
Yes.
and we already knew that c was 0 and negative and +4. I
And positive
I,
4. Very good.
I
Yes.
essentially just said how many units does it take to go from 0 to -3 to 0 to +4, which
Yes.
is 7.
It's 7. Very good, my boy. Right? Very, very good. So I hope you all hear that. Or what you can do is, are you still there on Tatile?
Yeah, I'm so yeah.
Yeah. Remember, what you can do also, guys, you can also use the distance formula, because the coordinates of C is 0 is to 4. The coordinates of D is 0 is to -3. So you can just put those two coordinates into the distance formula. You'll still get 7 units. Does it make sense?
Yeah, I just mainly did this one because it's more efficient.
Yeah, it's more efficient, and it's not time consuming. Whereas the distance formula, it's time consuming. Does it make sense?
Yeah.
Okay, thank you so much, my boy. Hey.
You're welcome, sir.
Okay, cheers.
Bye.
Okay, thank you so much, Ontadile. So it's 7 units. So basically, what we're going to do, guys, here, they used the 4 minus minus 3, as Ontatile told us, from 0 to D, it was -3 units. And then from 0 to C, it was 4 units. So when you add those 4 units and these 3 units, you're actually getting 7 units. So the length of CD is 7 units. I love the method that Ontatile gave us because it's very efficient. It's quicker to use it also. Whereas, yes, you can still get the very same answer even if you used the distance formula. But guys, remember, you are only writing for a specific time in an exam. You're not writing for months or weeks. You're only writing, it's either for 1 hour or 2 hours. So you need to know which things are faster, and you need to be comfortable with them. Come exam or your assessment time or your test time, you know that, okay, for this one, I always use this because it's quicker also. Because time, guys, time, speed, and accuracy in maths, it's very important, right? You hear people after a maths exam say, but I did not finish. When you ask them, they used thingy longer methods, you know. Guys, methods like when you are directing someone. Let's say now I want to go to a certain river. Or let's say I'm moving from Gauteng to Durban, you know. I'm just making an example. There are so many routes that I can take, but at the end of the day, I'll reach Durban, you know. But at the same time, I need to look that, okay, I need to save petrol. In order for me to save petrol, which route that is quicker can I use in order so that I can arrive on time? I'm sure even you guys, some of you going to school are walking, some of you going to school are using public transport, some of you going to school are using private transports. So even you guys, whether you're walking or you're using a transport, you always find an alternative way where you arrive at school on time. Am I lying? No, I'm not lying, guys. I'm actually speaking whatever it's happening. So even in maths, guys, you must always find something that is quicker and it's also understandable, you know, because you don't want to sit there in an exam and spend 5 minutes on two mark question. Do you get my point? You can spend 5 minutes on a 6 mark question or in a 5 mark question. Do you get my point? But in general, always try to find something that is quicker, and it comes with practice. The more you practice, guys, is the more you're going to be familiar with lots and lots of things, is the more you're going to explore and experience other formulas and stuff. Okay, thank you so much, boys and girls. Now let's look at 5.32. It says equation of a straight line through A and D. So let's determine the equation of a straight line through A and D. So basically, they are telling us that there's a straight line also here. There's a straight line through A and D. It's invisible though. Basically, if this was on a hard copy, I was going to say draw this with a different pen. Basically, they are saying to you, there's a straight line through A and D. Determine its equation. The straight line through A and D. Remember, I said to you, in order for one to have a straight line equation, one must have either or two things. Must have either 2 points or 1 point and a gradient. So in this case, we've got point A and we also have point D. So we've got 2 points. Therefore, we can get the equation of a straight line. Or if maybe, let's say you were given what? You were given 1 point and a gradient, still you were going to get what? You were going to get the equation of this straight line, boys and girls. So who can tell me what's the first start we can do with so there's an invisible straight line here through A and D. Who can tell me the equation of a straight line through A and D? Let's hear, guys. I've just given you a hint. You should know your straight line, guys, from grade 9. You should know your straight line equation. Remember, just to remind you, how does the straight line equation looks like? Let's go to our formula sheet. So basically the straight line equation is this one, guys. Y is equals to mx plus c. So you need to know how to get m, you know, and stuff like that. C, y, who can tell us? Let's go back to the main question. But remember, this straight line passes through A and D. And you do have coordinates of A, you also have coordinates of D, because 5.11 asks for coordinates of D, 5.21 asks for coordinates of A. So you do have two coordinates. So you can get a straight line of your equation of a straight line through A and D. And remember, guys, we've dealt with this also in your what you call in your analytical geometry. Okay, guys, hello. Guys, can you hear me? Hello, hello. Okay, I don't know what was happening, guys, earlier on. I'm not sure what was happening. I heard some sounds. I don't know. Sorry about that, but let's continue, boys and girls. I'm really sorry about that. All right, guys. So basically, guys, we're still on 5.32, right? So basically, we're looking at the equation of a straight line through A and D. So first thing first, you must calculate the gradient through A and D. So how do you calculate the gradient? Y over X, right? Perfect. All right. Okay, cool. So basically, if you look here, boys and girls, I'm just going to take you through here. Here's the equation. Sorry about that. But here's the equation of a straight line. Sorry. I don't know what's happening with my mouse today. Okay. Okay, cool. So basically, you must have your ymx is equals ymx plus c. So basically, you're supposed to calculate the gradient of A and D. Basically, they got -3/2. Then you choose any point, whether you take point A or you take point D to get your C. So it's either you take your point A or your point D to get your C. So you can take this one or that one, and you're going to substitute. In this case, we took point A, of which point A it was -2 and 0. So where there's y, it's 0. Where there's x, -2. Then we solve for C. C is -3. Therefore, the equation of your straight line is y is equals to -3/2x minus 3, right? And don't forget, guys, that remember now, if you were to draw this straight line here, can you see this is a downward sloping, and it makes sense for us to get a gradient of -3/2. So please, guys, okay, perfect, Aaron got it. I already showed you the solution. Here's the solution. Someone is asking, say, please show us the solution. Here's the solution. You need to be able, though, how to calculate the equation, the gradient. So the gradient is changing y over changing x, right? That's how they got -3/2 using the gradient formula, using 2 points, your point A and point D. Perfect. Now let's look at this one. It's the last question. It says, for which values of x is f of x greater than 0? For which values of x, boys and girls, is f of x greater than 0? We've dealt with this one several times, guys. This one, we did it now and then. And you know it from your algebra. This is part of your inequalities equations, guys. So you should be comfortable with this also. We did it a lot last week. I think we also did it sometime, not yesterday, but on Friday, we did something like this, and they always ask this one, guys. So it says, where there's an equation of f of x, put it and say greater than 0. So who can tell me which values of f of x will be greater than 0? Going once, going twice, going thrice. Okay, it seems like you guys are quiet today. I'm not sure because it's cold or something, but I'm just going to take you through also. So basically here, f of x is greater than 0, right? So we know what is the equation of f of x. So we need to go and check the equation of f of x. So basically f of x is our parabola. However, the equation, it was not given, but we can compute our equation because we got the values of A and values of Q from 5.22. So basically we can solve for X. So we take f of X equation and say greater than 0, then we solve for X. Then we can see which values will be greater than 0. It's -2 and 2. So basically it's your X intercepts. It's these your point A and point B basically. Perfect. So you are solving for X using the equation of f of X. Perfect. Then now this one says to you, the last one says to you, for which values of X is F decreasing? Where is F decreasing? For which values of X? So here's the X's. Here are your X's. Sorry. Just trying to scroll up. So your X's are lying here. So for which values of X in your f of X or in F, it's decreasing. We know, guys, that this cross, we call it a Cartesian plane, right? This cross, we call it what? A Cartesian plane. So anything that is lying here, F is increasing. But anything that is after 0, I mean, yeah, here it's your negative. If you know your integers, your number line, right? It's decreasing. So it's from 0 till to, or it's -2 to 0. That's where your values of X, F is decreasing. Basically, does it make sense? Because here I'm just going to show you basically with the solution, right? Where X is greater than 0, or where X is the element of element 0 to infinity, basically. That's where the F is decreasing, basically. All right. Now let's look at this one, guys. Question 6. Now, question 6, you are given a hyperbola. Can you see this is a hyperbola equation? If you go to your formulas, if you check here, you are given a hyperbola. Your hyperbola graph is y is equals to a over x plus q. So basically, this is a hyperbola graph, the one that we supposed to do. So now, if you go back to the question, it says the equation of the function g of x, a over x plus q passes through the point 3:2 and has a range. Y is the element of -infinity to 1 and 1 is to infinity. So basically we know the range of which is the asymptote, the line of the asymptote, guys. It's given by y is equals to 1. So it says determine the equation of g. It's easy for us to determine the equation of g because we do have 1 point and we also have what? The line of asymptote, of which is our range, meaning your range is your q, basically. So you can just substitute and get your a, then you can have your x and y. This is your x, 3, your y will be 2. Then you can substitute 1 in your q. Then you can get your value of a. After getting your value of a, you can put your equation, basically, right? I can see Aaron got 3 over x plus 1. Very good, Aaron. Let's show everyone how we got 3 over 1. Aaron, can I unmute you? Aaron? Let me check my chat box. Okay, he's saying yes. Hello, my boy.
Hello, sir.
How are you, my boy?
I'm fine.
Great, great. So can you please explain to us how you got your answer?
So for the function fg of x passes through the points 3, 2. So since the what's this? The
no, we don't call it 3,2, Aaron. It's
3 to 2. And
yeah,
then
3:2. Very good. Yeah.
And then we use the what's this? The what's this? The formula of what's this?
Of a hyperbola.
Yes, you say y equals A over X plus Q. Then where there's
Yes.
the Y, you fill in the 2 from the points. Where
Yes,
there's
very good.
Then where's the X, you fill in the 3.
Very
And then
good.
you what's the solve for A, then A equals to 3. Then where there's the A, you put the 3, so 3 over X plus 1.
Very good, guys. I hope you all got that, but let me explain to everyone. Thank you so much, Aaron. Hey, that was perfect.
Thank you.
Okay, thanks a lot, Aaron, for explaining to us. So basically, what Aaron said, it's actually correct, basically, right? So if we look, guys, here, we must solve for A first, right? So basically, your g of x is equals to A over x plus q. Remember, g of x, guys, is the same as y, right? So you were given the point as 3 is to 2. So 2, it was your y coordinate, and 3 was your x coordinate. Therefore, you must solve for A. How do you solve for A here? When you multiply and say, when you multiply by 3 throughout, you'll get A is equals to 3. You should know how to solve for A by now. Therefore, g of x is equals to 3 over x plus 1. Remember, I said this one is the value of q. This is what is your asymptote, guys, your range. Remember, I spoke about the range, that it's the maximum that the graph can reach, right? Or the minimum that the graph can reach on its y-axis, basically. That's your q. Remember yesterday I explained about the q, that if it's a minus q, meaning your graph is decreasing. If it's a plus q, your graph is increasing, right? So here we got 3 over x plus 1. Then now 6.1.2, it says the equation of H, the axis of symmetry of G, which has a positive gradient. So we must determine the equation of H, meaning in other words, H of X, the axis of symmetry. Remember, when we talk about axis of symmetry, we're speaking about mirror of G, which has a positive gradient. How can we do that, boys and girls? Who can tell us? It's one of the challenging questions, I know, but I'll be so happy if some of you can try. All right, guys, do you need 30 seconds to think? Or, yeah, okay, let me just tell you how I got it, this one, or how can we get it? Because I'm looking at the time. If I'm giving you more time, guys, we're going to delay and we have to finish this question by today. Right. All right. It's perfect. So they are speaking about the symmetry. So h of x is equals to x plus 1. That's where it's going to have a positive gradient. Why, guys? Remember, your 1 was what? Your 1 was the range. So you're just going to say x plus 1 with a positive gradient, because remember here, this is sort of like your straight line formula where there's always an invisible 1 here. Remember, this can be written as h of x is equals to mx plus 1, basically, right? So here there's an invisible 1 that gives us a positive gradient, basically, guys. It was easy and straightforward, but you're supposed to think. Now, 6.2 says, sketch the graphs of G and H, right? On the same system of axes, meaning on the same Cartesian plane. Clearly show all the asymptotes and intercept with x's. So basically they're saying, take your hyperbola graph and your straight line graph, draw them into one Cartesian plane. Basically they want something like this. They want your two graphs to be drawn in one cross. We call this cross a Cartesian plane, boys and girls, right? So basically, we need to draw the graph. So I need to show you how to draw the graph, guys. It's very important. Remember, as much as you know how, you need to know how to interpret the graph, you need to be able how to draw it, because they'll always say draw a graph. Also, you need to be able how to draw your graphs, guys. Very, very important. So basically, I've inserted here. So we know that, let's start with an easier one. The easier one was h of x is equals to x plus 1. We know where is plus 1. You must add, it's where your straight line graph cuts your y-axis. So it cuts at what? At 1. And we know that its gradient, it was an invisible 1, positive 1, which means now it's an increasing slope. It's not a decreasing slope. So it needs to face like this. And we were told the asymptotes of g of x, that is y is equals to 1, you must draw your asymptote. So your graph will lie in quadrant 1 and quadrant 3. We call these quadrant. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You'll see when we do trigonometry, we're still going to speak a lot about quadrants, right? So your graph basically looks like this, basically. Perfect. So I'm just going to show you guys so that you can have a look to your graph and see and interpret it quite a lot and see whether does it make sense to you before I can move to the last question. So this is how your graph looks like. I know some of you are still copying it down. Some of you are still taking pictures. You are more than welcome to do so, boys and girls. It's up to you which things you want to do. Now, 6.3 says write the equation of the asymptotes of f if f of x is equals to negative g of x plus 5. So they are saying to us, we must write the equation of the asymptote. So we must do the new graph. The new graph will be f of x. So we must take the equation of the g of x, but we must put a minus g of x, and we must add a 5. So remember there was plus 1. We also need to say plus 5. Remember it was 3 over x. So we need to say negative 3 over x plus 1 plus 5. So now the new graph or the new equation of f of x, it will be negative x over 3, right? 1 plus 5 is 6. So your asymptote will be what? Will be y is equal to 6, basically, right? Let me just show you here. So, I mean 4, basically, not 6, sorry, but 4, because here the minus is outside, 4. So basically, this is what your asymptotes will look like. So there was a negative here, then here you had to substitute by your g of x plus 5, right? Therefore, you'll get negative 3 over x, then negative times plus 1 is negative 1. Therefore, negative 1 plus 5 is plus 4. So your x is equals to 0 and your y is equals to 4, basically. That's how easy it was, boys and girls. I hope it makes sense. Until we meet again tomorrow, guys, have a lovely evening. Goodbye.